Hello, everyone. So welcome back. So we're talking. We've gone a lot through the algorithms and all that. So we're going to take a step back a little bit, and today we're going to delve into the wonderful, and I mean it, wonderful world of computers and their history. Yes, that's right. Computers do have a history. So, first of all, what we're going to do is we're going to talk about what an actual computer is, so we can at least eliminate some of the other things. Okay, so a computer is an electronic device for storing and processing data. Okay, according to instructions given to it in a program. Okay, now I think that's a pretty solid definition. The only probably word you might want to argue with is the word electronic. Okay, and as you see from the history of computer science and computers, there's a lot of non-electronic things that probably could be considered computers, but it's probably as good as definition. I suppose the key thing about it is, when you think about it, it stores and processes data. So it does it, not you. That's the kind of what they're getting at there. It stores and it processes the data, and it does it according to instructions given to it in a program. So there's a program entered into the computer. It takes the data, processes, stores it, could output it, whatever. So there's a lot of things that need to add together to make it an actual computer. So listen, let's give it a bit of a kind of a history lesson. So you think that, it's actually not that long. It's only just over 200 years old, the real kind of nexus of this. So I suppose before the 19th century started, so before 1800s, basically, the what we would have considered computers were basically adding machines, abacuses, that type of device. There had been people would have conceptualized these things, and what allowed computers, or the history of computers, to start up was actually, and we'll talk about this quite a lot, was another industry, and that was watchmaking. Okay, watchmaking. During the 16th and 17th century, the British started to flex their power militarily in the navy. And what made the British so good, and what made their navy so good, and ultimately what allowed them to have such a giant empire that spanned the entire world, was their ability to accurately navigate. And to navigate accurately, you need two things. You need longitude and you need latitude. Now, one of them is pretty easy to figure out. Latitude is pretty easy. You can figure out how high or how far or how low you are above the equator pretty easily with the most basic technology. Okay? Longitude, though. The only way you can figure out longitude is if you have a very accurate watch. So the Brits put a lot of money, a lot of research, and paid people a lot of money to come up with ridiculously accurate clocks that would never lose their time on long voyages, thus allowing them to accurately figure out longitude. But as a consequence of this kind of explosion in watchmaking, it allowed for smaller, more miniaturized mechanical devices. And there was an explosion of this in the 18th century and 19th century. There's plenty of examples of what's called automatons, okay? So real life looking humans and animals that are really clockwork. You'll see them as a lot of them were produced in Russia, because it was just like, it was a sign of wealth and opulence and all that. But we're going to start really in 1801 with a man called Joseph Jacquard. Okay, Joseph Jacquard worked in the the fabric and textile industry. Okay, and back then you had things like the spinning jenny and the loom. Okay, and with the industrial steam age, they could automate a lot of this. But you still needed humans in order to make sure that the fabric was being produced to the correct patterns for whatever design was on the cloth. And Jacquard created a wooden punch card with holes, okay, which, when air was passed through the holes, would deflect the shuttlecock as it moved backwards and forwards through the loom. Okay? These were the first programs. And we will see that they existed for quite a long time, these programs, in this form, this punch card form. Okay? So Joseph Jacquard produced the first, literally, program by punching holes in a timber frame through which air would pass, which would create different patterns on the cloth. Okay, in 1822, along came a man called Charles Babbage. Now, the British government paid this man a hell of a lot of money to come up with what he called the difference engine. Okay, the difference engine was a steam-powered mechanical counting machine that used cogs and wheels where you would input particular formula and it would output the results. Now, he worked in close work with a lady called Ada Lovelace. Now, for those of you who do English or honors English, she was the daughter, the only legitimate daughter of Lord Byron. So you might know who Lord Byron is, and that's his only legitimate daughter. She was she developed the world's first algorithm for programming Babbage's difference engine. Unfortunately for Babbage, while he knew what he was doing, the technology just wasn't there to be able to do what he did. And it wasn't until the last century, the 1970s or 80s, that we were able to actually, using his blueprints, build the engine that he wanted that could do it. And you can go and visit it now in a museum in England, and it actually does work. Okay, so they're probably the first two in the history of proper computer science who are trying to build a machine to compute. Okay, so fast forward to 1890 and to probably a man most people will never heard of, Herman Hollerith. Now, Herman Hollerith would have been aware of all this, and Herman Hollerith came to the United States government with a solution to a big problem they have, because they were trying to count everyone in America. And everyone in America in 1880 was a tough job because they were spread out so far and there was so many of them. You know, there was nearly 100 million of them back then. Okay, so the American government figured that this was going to cost millions and millions, and millions back then would be billions today type of job. Okay, millions and millions of pounds or dollars to do, and would take 10 or 15 years. So by which time the census would be, pointless, because they were taking a census every 10 years. If it's taking 15 years to get the results, well, by the time you got the results, the census, everything's moved on too far. So what he did was he used this idea of Lovelace's and Jacquard's algorithms and punch cards to when the census enumerators, the people who took the census, when they brought them back in, instead of writing them on a big sheet of paper, they'd put them into a punch card in a particular sequence. And then his machine was able to calculate from the holes in the punch card and count them up very quickly. So instead of taking 10 or 15 years, he got it down to 3 years. And he saved them over £5 million, or $1 million, which was a lot of money back then. A nice, interesting, this poor man, he wasn't that poor by the time he was finished that. Mr. Hollerith went on to form a company, and that company became IBM. be industrial business machines. Okay, and we will see them turn up throughout the history of computers. Okay, so we're up to the 1890s. We're not too far. We're only about 130 years ago now. So who comes next in this? Right. Well, I suppose between the 1890s and the kind of 1920s and 30s, nothing much was happening. And then, of course, things started to get a little bit dodgy in Europe. Okay. So you had the Germans and the Brits and everyone that were just getting a little bit dodgy. And in 1936, an Englishman called Alan Turing conceptualized the idea of a thinking machine, which could perform any possible calculation if it got the right information and it understood the right protocols, in other words, the right algorithms to do it. Okay. We are going to talk a lot more about Alan Turing in a separate video, so I'm just going to leave him there in the timeline. Okay. In 1941, an American called Atanasov built BUILT, the first computer that could store memory. Okay, so it could store data in memory. Okay, and you see what's happening here. It's getting shorter now. Everything's getting shorter in time. There's smaller gaps because things are happening. We've got World War II sniffing around here. In 1943, right at the height of World War II, ENIAC was made. And this was the key. Okay, ENIAC was the first electronic numerical integrator and calculator. Okay, the very first one, 1943. Okay, it had over 18,000 vacuum tubes. Remember, we talked about this before. Vacuum tubes are the precursor of transistors. They look like light bulbs, and they allowed the ones and zeros basically to be produced. 18,000 of them. Okay, and I think it was the size of a factory. The whole machine was huge. Okay, the Americans used it for tracking ballistic trajectories and stuff during the World War II in the Pacific Theater of Operations or something like that. Okay, helped the war effort massively. Okay, in 1946, just after the war, okay, the first solid transistor was made. Okay, so that means it didn't need bulbs anymore. This was a solid transistor. Okay, in 1953, Grace Hopper, again an American lady who worked in the Navy, I believe, produced what's called COBOL, which was the first computer language that could be used by other people. Basically, it wasn't just hers on her own. It was produced by other people. Okay. In 1958, you can see how close it's getting with the first integrated circuit. Okay. And then in 1969, would you believe, we had the first operating system, Unix. Okay. First operating system. So look at that. In the space of 20 years, that's it. In the space of 35 years, you've gone from Alan Turing conceptualizing, then building his Enigma machine, or his Enigma breaking machine in Bletchley Park, right up to the first operating system for a computer. Okay, so again, after that, 1970, we have the big boys arriving. Intel is founded. Okay, literally just a decade after the first integrated in 1971, we have the first floppy disk that allows for the transfer of data from one computer to the other portably. Okay, without having any real problems. Okay, 1974, sorry, the first personal computer that you can buy and bring home. Okay, literally that was it. Unbelievable. Okay, After that, then it gets really crazy. Okay, so 1975. Well, 1975 and 1976 are two of the most important years, because in 75, a young man called Bill Gates, and in 1976, two young men. Well, I should say Bill Gates and I think it's Steve Allen, isn't it? I think it is. And then Wozniak and not Steve Allen. I can't think of his name. Yeah, it was Steve Allen and Steve Jobs. Then so Jobs and Wozniak in 1976 created Apple. Okay, and then it just starts to flood from then. Lots of things happen in the meantime. For example, Microsoft had been subcontracted to work for IBM. Okay, and instead of building an operating system for them, which they didn't. IBM did not secure the operating system as an exclusive right, which meant that Microsoft could sell it to all the other companies producing personal computers, which is why Microsoft became the dominant operating system for computers at that time. Apple then started producing computers which had a mouse, which had color. Okay, then Microsoft stole the first actual in 1976 when Apple was formed. Wozniak and Jobs produced Apple One, the very first of their computers. Okay, in 1985, Microsoft produced Windows. Okay, they stole it basically. Well, they didn't steal it. They stole it. They stole it from the Apple operating system, OS 1. Okay, they basically just cloned it. Okay, but the interesting thing about it is, and people don't really know it, Apple went bust. Okay, Apple went bust in the kind of mid to late 80s, and they were actually saved by Windows or by Microsoft. Microsoft loaned them something like $200 million in the late 80s to keep them afloat, in return for Apple not pursuing a law or not pursuing a legal intervention because of what Microsoft did to Apple in terms of stealing their operating system. So it got very convoluted. So at one point in the late 1980s or early 1990s, Microsoft actually owned Apple in terms of the amount of money they'd given them to keep them afloat. Okay, so just all these weird little things started happening. Okay, in 1990, I suppose there's the next red is Tim Berners-Lee develops HTML, hypertext markup language, which allowed for the World Wide Web to actually be the World Wide Web. Okay, but when we talk about the World Wide Web, remember, we're not talking about the internet, we're talking about the World Wide Web. We're talking about the visual interface and the movement of data and how it looks on a screen. We've talked before about what the actual internet is, and that internet existed a hell of a long time before the World Wide Web. Okay, remember, it existed truly as a deep web where everything was just stored on LANs between different. And then I suppose there's been a lot of things that have happened since then, but I suppose the one red letter date, the one that really kind of changed it all. And again, if you look into the history of this, it was just good salesmanship. In 2007, we had the iPhone. Okay, the first proper smartphone. There was smartphones before them, but they made that leap to make it a full screen, fully interactive. And the world has not been the same since that point, 2007, when you think about it. Okay, we're only 13 years on since that point. But in those 13 years, the fact that we have portable computers in our hands does make a massive difference. So there's a brief history of computers. Okay, so we will talk a lot more about Turing. He is the man. We're going to do an awful lot more. Remember, we talked an awful lot about von Neumann. Von Neumann I haven't put von Neumann here because we talked about him already. Remember, von Neumann's in around the 1940s as well, with his conceptualized CPU and the von Neumann architecture. He's in there as well. But Turing is the one we really want to have a talk about because he laid the groundwork for everything that came afterwards. Okay, thank you very much, lads. Goodbye.